do you think companies are open to this? Are organizations open to the idea of integrating? Of course, they are. But what are the key challenges that you see, especially in legacy organizations?
Yeah, it's a little bit challenging in a very old legacy organizations, large organizations. We see that thing is not that challenging in a kind of startup kind or a younger organizations, because these two are silos words and they're huge in their own way. But organizations have realized the need for this kind of integration. So because these two are different platform, integrating those two is very important, and that's where PTC is investing a lot of resources, time and money to really integrate this very seamlessly, so that they can exchange, they can collaborate and have that holistic view. But definitely, to answer your question, yes, the organizations are open, and this is definitely one of the main topic in their digital transformation journey today. For their when you put their digital initiatives for the year, the systems engineering, model-based systems engineering, ALM and integration of ALM and PLM, and these I see as the most top digital initiatives for any organizations.
Mr. Raina, do you see, how do you see whether you find it challenging in your own organization, or has it been easier for you to understand this transition and work on it? And the second thing is, what are the key challenges? Because you have so much experience over the years. What are the key challenges that you see with this transformation, where you are safeguarding yourself? Maruti Suzuki is specifically emphasizing on those safeguards that you want to put.
Well, I think,
which also includes cybersecurity, and how are you approaching all that?
Yeah, thank you again for this quite complex question. First of all, coming from Maruti Suzuki, I would say I think our key pillars are that we are a very open and a learning organization. So I think we believe in continuous change, and I think that Japanese philosophy of Kaizen, I think that is part of our DNA, and we always try to learn. And what Dhirendraji, I think he explained the whole aspect very, very lucidly and very aptly. I think I fully agree with him, and I think within our organization also, we are trying to evolve. Definitely, Maruti Suzuki being a very big organization, and there are many stakeholders, but I think with a common objective, how we are taking everybody together. And typically, I think I would say that today, when the developmental targets are getting set, that time we clearly have a goal that how we are handling the hardware part, not only electronic hardware, but hardware, that structural part, how that development is getting handled, and how the software development is getting handled, and how the validations are getting checked for both the aspects, because they become very, very important, because they are the quality gates, and how those are getting evaluated, so that how that hardware and software, they finally marry together to make the vehicle. So I think, because this is the need of the hour, as I rightly said, when we have multiple programs running together, multiple powertrains, we definitely have a philosophy of multi-powertrain concept, where we are developing a conventional ICE to hybrid to CNG to EV to hybrids. So I think all sets of powertrains are there, and every powertrain has its own set of challenges. And with that developmental challenges, I think how we are integrating and handling all the programs together. So I think definitely it's a very complex puzzle to solve, and the intention and intent is how we are able to successfully meet our milestones and make the customers happy.
Interesting. Ajayji, do you think that digital technologies like digital twin, with what Sandeep San has said, testing software with the hardware is one of the biggest puzzles at the moment. Do you think technologies like digital twins, physical simulations, that come into picture, especially at places like this, when you have a hardware design, but you're not sure whether the lines of code written by your team or by some other team, would they be able to run on that hardware?
Very interesting question, first of all. Let me answer in a bit different way. when we manufacture any vehicle, all of OEMs, the biggest point for us is how do we know how it is going to perform in the field? Traditional way has been we manufacture, observe certain amount of vehicles, and basis that the decisions of improvements, process, quality are taken. Now with connected vehicle, with lot of telematics and IoT data coming in, what has happened is it has amplified our ability to get the real behavior without visiting the field. That is first part. And second, using that data which has been coming from actual vehicles from the field, the ability to I'll say synthesize synthetic data or an artificial data over and above to simulate the various scenarios is now made possible. Now that is what is getting fed into a concept called digital twin. So to answer your point, yes, it does bring value in that area because we are able to get a lot of data which is from actual vehicles without physically visiting the vehicle and able to multiply, amplify, scenario based simulations are able to see how it is going to perform. What is the objective? Objective is that our vehicle is designed properly, and then when it actually goes to the right segment of the customer, e-commerce segment versus mining customers for us, or e-commerce customers, the haulage customers, the school bus customers, all play a different. The vehicles are used, operated in different conditions by different personas. So you are able to do all those things at the design stage itself. So it does bring a lot of value there in that area. Use it and make it relevant is where the difficult part is. That is where a lot of effort goes within the organizations to see how it can bring more and more value in product improvement.
Interesting. Gaurav, would you agree to what Ajay has said? Because you do a lot of digital twins and simulations back at Euler.
So yeah, I fully agree with Ajay ji. One of the points that he highlighted was that the entire field data is amplified. So how we are sort of using that is that our entire of course, the way Dhendra ji mentioned, the if we are not keeping the development cycle for the mechanical, embedded, electronics, powertrain, software, and all of them moving together and working more closely, the timeline that we are looking to execute, that gets delayed. And of course, after all of this is done, you can provide certain bench setups to certain teams to test their software, and the different team will have their own bench setup to test the powertrain. But from the perspective of the data that comes through, what edge conditions, what are the worst conditions that we need to keep in mind and make sure that they are not leading to failures at all, that is what has helped this data. So from a timeline perspective, agreed with sir, it needs to run together. Otherwise, if we don't adapt to that, the timelines get delayed. And the second one is that the TNV, we sort of, you can say we get segments of focus areas in my overall testing, that okay, this is my laundry list of items that the specific conditions that I should be testing, because we are looking at those, that these are the extreme conditions when my torque is going to the maximum, or my temperatures are going to the maximum, my current consumption is shooting up, how the different like we have looked at certain in the powertrain, like how the capacitors are getting impacted, and how, so all that data actually helps us that instead of maybe, let's say earlier we would, because we can nowhere replicate the kind of usage that goes in the field. But yes, that data sort of helps, like what are my edge case and critical conditions that we should keep improving in my overall testing cycle.
Interesting. Well, a lot of interesting terms, data, software, hardware. But one probable answer that Dhirendra already gave was a common platform. So if I was to look at the design at a data democracy level, if everybody working on a design had the similar access, if the software teams were working in tandem in real time with the hardware teams, and then the overall other vendors as well, would that help?
It is for the customer that you're bringing in functionality through software, be it AI or otherwise. Hardware is the enabler. So Can they work anything but a hand in glove? No, they cannot. The only thing here is that cost of compute in hardware has been following Moore's law. It's getting cheaper year on year on year. It's my belief that we are sitting at the largest size of models around AI is concerned, or the largest sets of data packets that are on your firmware level, on your safety levels, on your encryption levels. You're at the largest size. So from here, my strongest belief is that if you hold the amount of compute you have available on the vehicle, software is becoming smaller and smaller and smaller will allow you to start having more and more headroom for more features to come in. Because overspecking hardware will not make business sense today. But I need the product to last 10 years. So the hope is only that software will become efficient. 2 years from now, it's going to be a different conversation where my hardware is probably already half the cost it is right now, and this cycle keeps evolving. But where we stand in 2026 and somebody is making a platform choice, or somebody is picking 5 nanometer chipset to take to automotive production in, let's say, the next 2 years or 3 years, that's a call that has to be made today.
Yeah.
Because automotive cycles are not I make it now, ship it to the customer in fall, and then next fall I have another product. No, that's unfortunately not the cycle automotive. And I think enough has been spoken about testing, and I think that is a real way. What's the worst that happens when this device fails? You put it out in the sun, on your dashboard, and it just says overheating. The worst that happens is you can't make a phone call.
Your software, your apps crash.
The phone shut down, that's it. When a vehicle shuts down mid-driving, you're at 100 kilometers an hour and now it's shut down, that's a different conversation altogether.
Yeah.
And that's where the degree of testing between this and an automotive is like a millionfold more rigorous. So hardware cycles are longer, while hardware is the piece enabling all of this in terms of software defined vehicles or domain controls. We're using a lot of terms, but essentially it's the end feature functionality which is being enabled. The hope here is that choices you make today and the features that will come in the future over the next 2, 3, 4, 5, 10 years will start becoming efficient enough that we can fit them into the same hardware package. Now, classically, has this happened? No, it has not. Like I think ADAS was spoken about. That package was 10x larger than every other compute on the vehicle.
Yeah.
So then a cutoff came in that, okay, only after this generation, when we do an actual hardware insertion, will these features become enabled. Like today, level 2 ADAS is almost available on most new vehicles.
Yeah.
So unfortunately, hardware does not have the elasticity that software does. And that is the only piece that's standing between you and a hospital right now. So we need to ensure that while we plan for headroom, we plan for feature sets, we plan for everything digital, it runs on a board and a chip. Can't miss that piece.
Mohal, I have one more question, which is again Apple and Google. Apple had its map, but ultimately Google Maps is what everybody uses. And the question is whether to do it yourself or whether to get it from outside, the software. Because everything is cost and it's changing very fast for an OEM like yours. How do you make that choice? Because it also has its own benefits and potholes.
So I think not me, I think Jim Farley in a podcast answered this quite well a few years ago, that as an OEM, and let's say I don't have the software defined vehicles today, I have 7 different domain controls. I buy them from 7 different suppliers. I get them in 7 different styles of writing code in 7 different languages on 7 different pieces of hardware. Now tell me, if there is no one common language between all of us in this room, how in the world are we expected to communicate?
Yeah, you already answered it.
That's where it breaks down. And that's where we believe very strongly that even if we might not have 100% control over the hardware, we absolutely need 100% control over the software, because that is what has been defining. I mean, even if you use the Apple Google ecosystem conversation, why does everything work seamless in Apple? Because it's one person designed it all, versus when you have different companies giving you headphones and phones, and there's mismatches which come in, sometimes they pair, sometimes they don't. So that trade-off, and especially in automotive, I strongly believe that it needs to be seamless. So software 100% in-house, and while I say 99% hardware, if you are doing software, you need the hardware to do exactly what your software needs to do. So by extension, you need to control both.
Dhirendra,
Yeah.
for everything that Mohal has said, if we consider testing for everything that he has just mentioned, do we put out a POC of a vehicle, do a test, collect data, and then create a digital twin, or first create a digital twin and then perfect the product? What's the right?
Yeah, so I think today, like we spoke about digital transformation, there is a little bit of digital twin that I can do before even you build a prototyping. And that's what I was in the early stage, I was talking about model-based systems engineering, right? Where you really build the system model and the software models, and there are tools available today, you model them, and there are system simulations that you can do it today, okay? So you can actually simulate the whole vehicle without even going into the concept design, even getting into a detailed design using your CAD softwares and all of that kind of thing. So there you get a little bit of holistic view, and of course do for that system simulation, like what Gauravji and everybody mentioned, the telemetry data can be used to really simulate those systems that what you design with the real-time data coming from the field, and see what is the battery's capacity, how much it is consuming, what is the speed, and all of that kind of things. A good holistic idea can be got with this system and software simulation, right? And then you go into the concept design, detailed design, build a prototype, and you test it. And versus directly you going there, when you compare these two methodologies, your area of errors and the time taken would definitely reduce. So I think a digital twin right in the planning stage or the earlier stage is like, if you again talk about the V model, if you see on the left hand side, where you really build your system and hardware architecture and everything built together, and do a little bit of system simulation there. So that is possible today. Technically, theoretically, tools are available, technology is available. I'm not sure how much that adoption of that is happening in the industry, but definitely to a very good extent that will help to reduce building prototype, testing, timings and all of that, and also the number of errors or the improvements that we can do.
Can I add to?
Yeah.
Please.
I think to what the discussions were happening, I think regarding the collaborative working within the enterprise, I think it is very, very important to understand that within the organization, when we are trying to build an automobile or a whole system, which is quite complicated, I think without co-development, things cannot be made. So I think different functions within the organization, and typically today the developments are more concurrent. When the models are getting made, so data is visible to all within the organization. So definitely the relevant authorization of change is assigned. So typically when engineering guy is working on the model, he is modifying the design, say based on certain virtual simulations, there are certain modifications which have to be made on the particular structure of the vehicle. The data is concurrently visible to his counterparts in other functions within engineering, and also to the colleague sitting in production engineering, who has to ensure that how that vehicle will finally get manufactured. And what I think most of us, we are talking about digital twins. I think definitely within Maruti, we have a methodology where we do all virtual checks of how the vehicle will get assembled, welded, or how it will get serviced later. So that is all done virtually before the drawing finally is released and it is issued for final manufacturing. And specifically on evaluations of software, what I think again Dhirendraji had a lot of conceptual discussions. I think typically organizations are transiting towards that, where a software skill sets itself within the organization, if you say what Mohal was talking about, yes, ideally, I think everything has to be within the organization. But I think it's not a picture of a perfect world, and things will evolve. So you need to have partnerships. You need to have that network through which you can acquire those required skill sets and support. However, definitely as OEM, one has to be responsible enough to see that whatever is coming out of you is safe and can meet the required targets of performance. And during this, definitely at virtual level and definitely at a semi-hardware level, I would say, controllers are checked. So those benches are there where a mule controller is made and you can inspect it virtually on a bench to see and fail early so that countermeasures are taken, and what you finally deliver is again up to the desired target. Because I think what Mohal also, I fully appreciate and understand what you say, that there are no scope of any relaxations or say permissible errors, specifically when it is safety. Because then the risks are too many. If a OEM ignores that there are very high chances that because of liability issues, you are wiped out. So one has to be very, very careful about when we are talking about this transformation and whatever is coming out. So I think that balance is very, very important, that yes, digital, software, everything is fine, but finally how you are transacting and you are managing both sides of the business.
Interesting. What you just said, Sandeep San, is basically referring to the digital thread, the idea and the consolidation of the digital thread, where everything from design to manufacturing is mapped.
Yes.
And OEMs are going that way.
Yes.
You've already put it here.
Yes.
So are you very close to achieving the absolute digital thread when it comes to design to manufacturing practice?
I think we are doing a lot of it, and the point is there is no picture perfect. There's always a scope.
So there's
of
no
improvement.
absolute.
There's no absolute, I would say.
It's a journey, basically.
It's a journey, and I would say that what I said in the beginning also, finally, whatever you do, it's not for the sake of meeting the objective of digitization. Finally, as an organization, as an enterprise, how you are able to generate that IP or whatever is the product what you are making. And if you are able to have a way where the organization can manage it, fine. It can be a hybrid mechanism where you are doing certain things traditional way and certain things the new way. So, but to answer you in a very short way, yes, because without that, it's not possible to handle complexities and when you are handling multiple programs.
So, Sandeep, would it be correct to say that now is the time where all your partners, whether software, whether component makers, tier ones, your EV charger providers, all have to be present on one platform, work together to create that, seamless product?
It's not about one platform. Yes, there has to be a way there where there is a seamless communication.
Data and design democracy.
Yes.
Yeah. Mr. Mittal, I wanted to ask this. Vendor partnership and vendor dependency seems to be becoming a little bit more important than it ever was, and it has to start at much earlier level as well, as I understand. So how do you see it?
Let me add it this way. When we develop any product, we see who are going to be the constituents of it. The constituents are not only material, but also people, process, and vendors, or we call them suppliers and partners. So basis that, when you look at the mix of it, you put in a framework called a DVF, the desirability, okay, what do we desire, and then the viability, and then the feasibility aspects. When you do this across all these layers, then you get your right answer, keeping customer in front, commercial angle in front, and then compliance, regulation. I think we are all talking about ADAS, we are all talking about vehicle controls, but what we have to see it, what is government doing in that area? That also we have to see. Is the infrastructure available on the road is going to support that? Do we have a right connectivity setup in India to support that? Highways, roads, cities, tall buildings, is there? Even the liability aspect was talked about. Okay, who is going to be liable in case something happens in a different way, which nobody wants? Is the vehicle, the designer of the vehicle, or the driver of the vehicle, or the person who has written that logic?
Maybe the government.
So that is where I think we have to see how government is looking at it, and they are doing it in the right way. Is they're trying to create the framework of policies going from information driven to action driven and enabling vehicle control.
Interesting. Ajay, do you see software teams? Because you work with a lot of software teams back at OPG. Do you see them working more closely with fleet owners? Because you are into fleets, you are one of the biggest fleet suppliers out there in the market. Do you see software teams sitting at your fleet owners' place and writing codes according to them? Is that also a necessity now?
I think it is important. Gaurav has already replied for that because data, whatever fleet you are deputing on that fleet, what is the requirement of those fleets? So that need to be understand, and gathering all those datas and modifying those with respect to requirement of the fleet owners. So like that, either it is performance related or it is some kind of a use case related, or it is related to weight and everything. So those data collections and improving those software with respect to fleet owners requirement, because everybody is having different kind of a requirement. Every fleet owner is having a different kind of a requirement, and software should have those kind of flexibility to modify those requirements and to provide those requirements to the fleet owners. Like that, Domino's is having different kind of a requirement. We have supplied to Domino's. Army is having different kind of a structure. They need more structured things, and some other fleet owners or commercial, those, because everybody is having different requirement, and to integrate those things, so flexible platform is required to provide all those requirement. So that is very important to integrate as a OEM for them.